Rational numbers. Earlier I have explained what are the rational numbers in the number system, and you are very much familiar with the integers and fractions. So let's discuss it further. Rational numbers. These are further divided into integers and fractions. In our earlier classes, we have seen fractions like 1 by 2, 3 by 4, any fraction which can be proper, improper, and mixed. So the numbers in this form, say the numerator is p and denominator is q. If the numbers are in this form, then the form is simply p by q, where p and q are integers. And integers can be negative integers, whole numbers, or natural numbers. Let's talk about it further. Suppose if I pick any number like minus 25. It's not in the PQ form, but still it's a rational number. How? If I write minus 25 by 1, the value remains same, and this number is in of PQ form. So the integers are rational numbers. In definition, the numbers of the form p by q, where p and q are integers. We have talked about the examples of this form like 1 by 2, 3 by 4. All these are integers. We can easily say here p and q are integers. This condition is fulfilled by the examples. Q is not equal to 0. This is the second condition. Why q is not equal to 0? Dividing any number with the 0 is undefined term. How? If I am taking minus 25 and I am dividing this number by the 0, what is the meaning of dividing? Dividing means equal shares. Equal shares among what? Among whom? If I have 0 people here, among whom I am going to divide this number? No one. Hence this is undefined term, and q cannot be equal to 0. It's 25 and this cannot be written. So q must not be equal to 0 to fulfill the condition of p by q form. That is, are known as rational numbers. All the rational numbers are represented by the capital letter Q, and the set of the rational number can be written as braces open PQ is such that, this is the sign of such that, PQ are integers and Q is not equal to 0 braces closed, because we have to put all the conditions inside this set. Rational comes from the word ratio, while the Q comes from the quotient. Let's write PQ forms 1 by 4, 5 by 100, 36 by 407. All are in the P by Q form and are rational numbers. Points to be remembered. Number 1. Just like natural numbers and the whole numbers, rational numbers are also infinitely many rational numbers. Just like the integers, we can represent rational numbers on the real line which extends endlessly. That means rational numbers can also be presented on this line endlessly. That means to infinity. That means these are infinitely many in numbers. Second, we have seen in the natural number 1 was the least number. In whole numbers 0 was the least number. But in case of rational number, there is no least. or greatest rational number. Third, 0 is a rational number, as we can write it in the form of 0 by 1. So 0 is a rational number. Fourth, every natural number is a rational number. If I pick number 67, natural number, and divide it by 1, then it is in the P by Q form. Hence, it is the rational number. Just like natural number, every integer is a rational number, as this one also can be represented in the P by Q form. Pick any integer number like minus 25. Earlier I have explained this example. So every integer is a rational number. Hence, rational numbers include natural number, whole numbers, and integers. Simplest form of a rational number. If we know the simplest form, then we know what is the simplest form of a rational number. So let's first talk about simplest form. If I write 1 by 2 or 2 by 4, do you find them equal? Yes, these two are equal. The only difference is this, that this is in the different form and this is in different form. But if I divide both these number by the 2, then what will I have? 1 by 2 simply. But can I divide this form any further? No, because this is a prime number and this is also a prime number. Or in another word, they are co-prime. So a rational number in the PQ form, all these are in the PQ form, is said to be in the simplest form if P and Q are integers having no common factor other than 1. I think this is the same definition for the prime. Whole numbers have only two factors, 1 and the number itself, are called prime numbers. Two factors only 1 and the number itself, and that is the condition getting fulfilled here. So these numbers are co-prime. This one is prime and 2 is also prime, so co-prime. When the numbers are co-prime and further cannot be divided, is its simplest form. Hence the definition is a rational number in the PQ form is said to be in its simplest form if P and Q are integers having no common factor other than 1. That is, P and Q are co-primes and Q is not equal to 0. I have explained simplest form, that the co-primes further cannot be divided, and in my previously explained videos I have mentioned why Q is not equal to 0, and this is fully explained in the video part 1 for the chapter number systems. So if you are interested, please go and watch this. Example of simplest form is 2 by 4, 5 by 10, 6 by 12, 10 by 20, etc. Simplest form of all these rational number is 1 by 2. How? If you divide this and this by 2, you will get simply 1 by 2. And by keep doing the same method with all these numbers, you will get simply 1 by 2. 10 1 ja 10, 10 2 ja 20, and you will get 1 by 2. So Further, it cannot be divided as these are coprimes. Hence, this is simplest form. Equivalent rational numbers. In the example of simplest form of rational number, I used 2 by 4, 5 by 10, 6 by 12, 10 by 20. And the simplest form of all these rational numbers was 1 by 2. It is clearly seen here that all these, as their simplest form is equal, they have equal values. Meaning of equivalent. Equivalent. That means means equal. Valent means value. That means equal value. Those rational numbers which are having equal values, as all these are having equal values, these are equivalent rational numbers. And this is the simplest form of the rational numbers. Hence the definition is equivalent rational numbers that have same value but can be represented in different forms. Example: 2 by 4, 3 by 6, 4 by 8. All are having equal values. Equivalent numbers.